Hi, welcome to a training session of Kaizen Copilot. In this video, we'll talk about station design. This module analyzes station video by performing time and motion study, station audit, and ergonomic zone assessment to identify the implement opportunities. To do so, first create a new study. Click on New Study, enter the station name, enter the product name, and select the video file. And then click on Create. This creates a new assessment for that particular station. In this preview page, you can watch the uploaded video before proceeding. After confirming the video, click on Mark Cycles. A video will consist of multiple cycles. It is important for us to segment that into individual cycles. So this page helps us do that. To do that, we need to identify the start action of a cycle. Like in this case, bringing a new unit to the table will be the first action. I'll mark the cycle start. Similarly, once the operator finishes all of the steps, and with the last step, we mark the cycle end action. To do this faster, we can use the forward button. Here, the last action will be the operator marking the part number and then removing the part from the table. I'll mark the cycle end action. Similarly, let's mark all the cycles in this video. We can use the forward and backward button for our convenience. Now in this video, we have marked 3, so I can click on the Save button. Now the video has been divided into 3 individual cycles, and we can review them all here. If the marked cycles are correct, then we can go ahead and select the master cycle. This cycle will be used as a reference cycle, which will be used for auto-segmentation and ergonomics assessment. There is no hard and fast rule for selecting a master cycle. It can be any of the reference cycles. Once I select the master cycle, I will click Next. In this outline page, we are supposed to mark the work region. To do that, first we have to select the number of work regions. Since we only have one work area where the operator does all of the work, we're going to be selecting 1. Then I'll click on the Mark tool. Then I will select the boundary where all of the actions of this station happen. After I do that, I will select any one line and put in the dimension. In this case, it is 28 inches. From point A over here to point B, this will be 28 inches. This will be a reference dimension for us to carry through the ergonomic source. Then I click on the Locate Operator tool and place this where the operator is positioned during the cycle period. Once I mark all of this, I click on the Next button. Here, we need to mention the number of steps performed in this cycle. In this case, it is 12. So I'll select the 12, and then click on the Next button. So on the back end, the AI runs and analyzes the video to perform time and motion study, ergonomic zone assessment, and then identify the work elements. The AI has analyzed the video and put in the following information. So it has divided the entire cycle into the mentioned number of steps, and for each step we have a corresponding video which shows what the activity is at this step. So here we can see that the operator bringing in the first element is identified as Step 1. Similarly, if you go to step 2, you can see it has been identified as the operator bringing in the next element and assembling it. Likewise, the AI would have divided, like how we do in our traditional time and motion studies. Not only this, the AI also estimates the work elements and identifies the work element to this particular step, and also provides the value add. And based on this work time, we have some questions that will help us identify the implement point. For example, can this step be eliminated? Or can some components in the assembled product be eliminated? By answering these simple yes or no questions, the AI will again give us a suggestion in the suggestions page. Now we need to enter the step name for each of the steps. Like for this one, it will be pick plate from the bin. Now I have completed adding the step name for all of the steps over here. Now, if you have any inconsistencies, or if you would like to modify, we can use the Edit Timing option. Here, we can either combine 2 steps or break the steps up and alter the segmentation. For example, here, I see 2 screws actions, which if I want to combine, I can do so. So I select the step and the corresponding step and click on Combine Selected. This typically will combine both of the steps and combine it as one step. After this is done, we'll move to the next page. In the Audit page, we have questions related to facility, standard work adherence, workplace design, and manufacturing waste. These are all simple yes or no questions. By looking at the video, we will answer these and try to find any improvement opportunity. For example, if we observe here, the operator picks the plate and then flips it by 180 degrees before installing it. So flipping by 180 degrees is really a non-value-adding activity, and it is a waste. So this question, like, does operator move parts or material from one position to another position unnecessarily within the workstation? Yes. So this is what we just observed. Likewise, we can answer all these questions to identify the waste and implement points. Once we filled out the audit page, we'll move to the suggestions page. In this page, we provide recommendations to improve the efficiency of the station. We have key takeaways, which provide suggestions to improve the process. For every step, it has an implement suggestion. For example, encourage workers to use smoother hand motion types rather than haphazard motion types. This is based on the evaluation of work element. And then we have the time and motion study result page, which will let us know insights like what is the actual time, what is the value added time, and the number of steps. It also provides a Yamazumi chart of this station and says the percent of value add and non-value add present at this station. And then we have this table, which offers the step name, the corresponding time, the standard deviation, as well as the work elements. This table can also be used to identify the implement opportunities. For example, in the 7th step, where the operator is supposed to place the screw and hand tighten, we can see the standard deviation of 4 seconds. So we'll just play the cycle to understand why it is the largest standard deviation. As we observe, the operator picked the screws and then is placing it and trying to hand screw. And we can observe him struggling to hand tighten because of irregularity or the unit is not stable. So this kind of implement opportunity can be identified by looking at this table and the video. Also, this table can be downloaded and used on the shop floor. And then we have station layout suggestions. Here, we have an image where we can see a marking of the ergonomic zones. And also, the AI analyzes what is the hand occupancy percentage of each zone. So working in Zone 1 and Zone 2 is most safe. And over here, we can see that the AI has detected that Zone 1 has 99.8%, which means this workstation is comfortable for the operator to work in. If there is any inconvenience to the operator, we have that highlighted here, and we also provide suggestion on how to relocate from one zone to another zone, which will make the work convenient for the operator. And then we have the Workstation Audit Results page, which will show the maturity of the workstation based on the audit questions. Here, the maturity is high, but still we have 3 Kaizen opportunities, which can make the maturity much better and increase the productivity. Also, we can use AI Suggest to get suggestions on the Kaizen points over here. For example, click on AI Suggest and write the description in detail, like provide the option to eliminate unnecessary motion in the workstation that is flipping of parts by 180 degrees before assembling, and then click on Generate. So this will generate some of the suggestions. So whichever one we feel is a potential one, we can just select them and click on Insert. So now we also have the suggestion piece here ready to be implemented. Also, we have step analysis. For each step, the motion economy is analyzed by AI, and it will determine if the action is haphazard or simple. If it is haphazard, we can always try to improve that. Now, with such detailed analysis of this station, we can easily identify the improvement opportunities and improve efficiencies. After this, we can go to the Notes page, and this will help us to document the implementation phase, like what problem you are solving, and any engineering notes on generated recommendations that we can write in here. That's all for station design. Thank you.